So today we are starting with current electricity class 10 physics part. Okay. So in this chapter we have to study the Ohm's law as well as terms related to voltage, potential. Then also we have to discuss about the uh, resistors, okay, and how the resistors are connected in series and parallel, okay, that also we have to discuss today. Okay, so I will try to cover as much as syllabus, but my main focus is on numericals. Okay, so people are struggling with the numericals, so I will keep uh, more focus on the numericals. Okay, so already we did lens, and that is light reflection and refraction, that already we finished. Those who are not attended, they can check that video once. Okay, so now we can start with the current electricity, okay, or electricity. So I'll give just idea about this chapter. Okay, what all are the formulas are there, and I will prove how to why resistors are connected in series and parallel. Before that, we can go for the electric current. Okay, so electric current. So if you take any metal, okay, if you take any metal, that metals are having more free electrons, okay, and when that free electrons get the energy, they constitute what? The electric current. And that electric current we are writing by charge. We are writing by charge by time. Okay, so here we can say that current or electric current is equal to charge by time. Charge is denoted by small q or capital Q divided by time t. Okay, and current we are representing by letter A, and current is measured in terms of amperes. Okay, current is what? Measure in terms of ampere, and current is also what? Scalar quantity. Okay, it is a scalar quantity. It only gives the magnitude. So here ampere. Okay, ampere is the SI unit. Okay, AM. So ampere is a SI unit to measure the current. So this is nothing but what? Current. So rate of change of charge is also known as what? Current, because as we are providing more and more energy, then charges are also what? Started constituting more and more current. So that's what it is divided by T. This is nothing but current, and always remember current is measured in terms of ammeter with the help of ammeter. So ammeter we are always connecting in series with any circuit. Okay, it's very important. So this is what about the electric current. Then after that we have one more device, that is a voltmeter, and voltmeter is used to measure the voltage. Okay, so voltmeter is used to measure the voltage, used to measure voltage, and voltage is denoted by letter V, and SI unit is also V. Okay, so volts we are writing, and after that we have a Ohm's law. Okay, take a screenshot of this first, then we'll go for Ohm's law. Take a screenshot. So here Ohm's law. What Ohm's law says that V is directly proportional to the current. As voltage increases, then current is also what? Increases in that circuit. So according to Ohm's law, here V is directly proportional to I. Okay, so we can write here this proportionality sign, we can remove. V is equal to, replace this by constant R into I. Okay, so R is a resistance here, and this resistance is measured in terms of ohm. Okay, we are denoted by this sign ohm. Okay, V is equal to I into R. As V increases, then current is also increases. V decreases, then current is also decreases, and the slope of the graph is always comes as V by I. Okay, so here this Ohm's law gives the linear graph as the circuit. We are assuming here circuit is obeying the Ohm's law. So here suppose we have the current, okay, on I, on the x-axis current, and here we have a voltage. Okay, suppose we have 2, 4, 6, 8, and here also we are taking 2, scale we are taking. So now suppose current is 2 ampere, then voltage is also 2. When current is 4, that means voltage is supposed to be 4. Okay, if voltage 6, then current is also what, 6. Like that, if you join all the points here, this gives what, a linear graph. So here V and I are direct proportion. Okay, and 1 ohm, if suppose they are asking definition for 1 ohm, so in that case V should be 1 volt and current should be 1 ampere. In that case you will get 1 ohm is the resistance. So what do you mean by resistance? Actually resistance is a device, okay, which opposes the flow of current. Okay, which opposes the flow of current is nothing but what, the resistance. Like that in next higher standard we have inductors, we have a capacitors. So they all are what, generating the resistance, means opposition in the circuit. Why opposition? Because they want to block some AC or DC component. Okay, so if there is a no control on the current, then it's very difficult that device will become what, heated and heated, and maybe what, there is a damage will take place. That's what this kind of devices like resistor, inductor, capacitor are there in the circuit. Okay, so here this ohm is also measured with the help of rheostat. Rheostat is a device where we can change the value of resistance. It is a variable resistance, and here if we take a resistance of any conductor, okay, afterwards we have this, I will explain that time also. If you take here R is equal to rho L by A. So this resistance is directly proportional to the length, resistance is inversely proportional to the area of cross section, and here rho is a resistivity. Okay, so here resistance is depends on the length of the conductor as well as it is inversely proportional to the cross sectional area, and it is directly proportional to the temperature. Resistance increases, temperature is also increases, and also it is depend on the nature of the material. So this is very important, and rho is nothing but what, resistivity, and this resistivity rho we can write it as R A divided by L, and its unit is rho. R is measured in terms of ohm, okay, and area is measured in terms of meter square, and length is meter. Meter and 1 meter is get cancelled, and ohm meter is the SI unit of the resistivity rho. Can you getting this? And everyone is getting what I am saying? Okay, so this is what we have the formula, and if we want to find out number of electrons, okay, we have the formula. We have one more formula, that is equal to Q is equal to Ni. Okay, Q is equal to N into E. We can find out number of electrons from this. Okay, so these are the formulas we have. So you can take a screenshot of this very important part I wrote on the screen. Okay, take a screenshot of this. Okay, first we finish the numericals based on this part, and then we'll go for the other part of this chapter. Okay, so write down some questions over here. Write down question. Calculate the resistance of 1 kilometer long. Calculate the resistance. Calculate the resistance of 1 kilometer long copper wire. Long copper wire of area of cross section. Area of cross section 2 into 10 raised to minus 2. 2 into 10 raised to minus 2 centimeter square. Centimeter square. Full stop. The resistivity of a copper is 1.623 into 10 raised to minus 8 ohm meter. 1.623 into 10 raised to minus 8 ohm meter. Okay, I'll repeat this problem. Calculate the resistance of 1 kilometer long copper wire of area of cross section 2 into 10 raised to minus 2 centimeter square. The resistivity of a copper is 1.623 into 10 raised to minus 8 ohm meter. Okay, so we have to find out here resistance, that is R. Okay, resistivity we are denoting by letter rho. Okay, and here we have to find out the resistance, and that resistance is nothing but what? Here R is equal to rho L by A. So when and how we can use the different formula. So now it is also using a formula is based on the given quantities. Okay, so here what are the given quantities? Here rho is given, density means rho is what? Resistivity of the material is given, that is nothing but 1.623 into 10 raised to minus 8 ohm meter. Okay, then after that they gave the length 1 kilometer. Length is given 1 kilometer, that means 1 into 10 raised to 3 meters. Okay, convert that into standard form, that is in terms of meter, and area we have here 2 into 10 raised to minus 2 centimeter square. Okay, so again it is in centimeter square. Convert this by multiplying 10 raised to minus 2, and it is square also. So 2 into 10 raised to minus 2 into 10 raised to minus 4 meter square, because 10 raised to minus 2 into 10 raised to minus 2 will become how much? 10 raised to minus 4. Okay, so now you can simplify this. So once you get this, they are asking here resistance. We have the formula R is equal to rho L by A. So I have rho, L and A, all these values. So substitute these all values over here. Rho is 1.623 into 10 raised to minus 8. Length is given 10 raised to 3 divided by area is 2 into 10 raised to minus 2 into 10 raised to minus 4. Now first you can collect all the powers over here. 1.623 divided by 2 into 10 raised to minus 8 plus 3. Okay, minus 8 plus 3 is minus 5. Okay, and minus 2 minus 4 is nothing but what? Minus 6. Minus 6 goes up, that will become plus 6. Okay, now minus 5 plus 6 is nothing but what? 10 raised to 1. Okay, so I will write here 1.623 into 10 divided by 2. So here 5. So you can simplify 1.623 into 5. Okay, do this. Do this calculation. Now check how much is the answer. 8.115 ohm is the resistance. Check, this is the answer. 8.1. Okay, getting this? Who all are there? Hriday, Azra, who all are there? Advait? Okay, leave it. Chalo. Write down next question. When a 4-volt battery is connected, when a 4-volt battery is connected, when a 4-volt battery is connected across an unknown resistor, there is a current of 100 milliampere. There is a current of 100 milliampere in the circuit. 100 milliampere in the circuit. Full stop. The value of calculate the value of resistor. Calculate the value of a resistor. Okay, I'll repeat. When a 4-volt battery is connected across an unknown resistor, there is a current of 100 milliampere in the circuit. Calculate the resistor. Okay, so very simple problem. Okay, so that you can apply the basic formula and find out. So check here what are the given quantities. They are asking us to find out the value of resistor, that is capital R. So here values are given. Battery voltage is given, V is equal to 4 volt. At least from the given unit you can identify what is given. Okay, and current is given, I is nothing but 100 milliampere. So don't forget to convert into SI system. So here milli is there, that we have to convert it into ampere. So milli we have to convert into ampere just by multiplying 10 raised to minus 3 ampere. Okay, so these notations you already learned in the lower standard. Okay, so now here this is given, then they are asking R value. So we know that Ohm's law, V is equal to IR. We are interested in R. So R is equal to V by I. V is 4 and divided by 100 into 10 raised to minus 3. Okay, so 10 raised to minus 3, that means here we can write 10 raised to 2 minus 3 is nothing but what? 10 raised to minus 1. So 10 raised to minus 1 goes up, it will become plus 1. So resistance is nothing but 40 ohm. Okay, getting this? Can you getting this kind of problems? Very simple 1 mark question. Maybe they will ask for one MCQ. Okay. Copied this. Okay, write down next one. Write down the maximum resistance which can be made. The maximum resistance which can be made using four resistor, each of resistance 1 by 2 ohm, that is half ohm, 1 by 2 ohm. Okay, is options are given. First 2 ohm, B 1 ohm, C 2.5 ohm, D 1.8 ohm. Okay, I'll repeat this. The maximum resistance with the maximum resistance which can be made using 4 resistor, each of resistance 1 by 2 ohm is A 2 ohm, B 1 ohm, 2.5 ohm and last is 8 ohm. Okay, maximum resistance. So here we have two kinds of combinations, that is series and parallel combinations for the resistor. So remember, the series, whenever we are connecting the resistors back to back, in that case you will get the maximum resistance, and when the resistors are connected in parallel, then you are getting the minimum resistance. Okay, so here they are asking what is the maximum resistance, and here each resistor is given of half ohm. So like that we have 4 resistors here. Okay, 4 resistors are there. We have to find out maximum R. Okay, so resistors are there as we are connected in series. So we know that total resistance is nothing but R1 plus R2 plus R3 plus R4. Because here we gave, they are asking us to take 4 resistors and they are asking maximum resistance of this resistor, and each resistor is having value half. So half plus half plus half plus half, that is nothing but what, 4 by 2, that is nothing but 2 ohm is the total resistance. Okay, so check which option is correct. A option is correct here. Getting this? Copy this or you can take a screenshot and then we'll move for the next problem. Write down a cylindrical conductor of length L, a cylindrical conductor of length L and uniform area of cross section A, and uniform area of cross section A has a resistance R, full stop. The area of cross section of another conductor of same material and same resistance but of length 2L is first option given A by 2 means capital A by 2, second 3A by 2, C 2A and D 3A. I will repeat this. A cylindrical conductor of length L and uniform area of cross section capital A has resistance capital R. The area of cross section of another conductor of same material and same resistance but of length 2L is A by 2, 3A by 2, 2A and 3A. Okay, so these are the options. Little bit we have to think on this. Okay, very good question. Here we have one cylindrical conductor whose length is L. Okay, I will draw the diagram also so that you will come to know that what they want to say. So here the cylindrical conductor like this we have, okay, whose length is nothing but what, small l, and area of cross section is capital A. Okay, correct, this much is given, and whose resistance is also given, R. Okay, so what they are saying now, the area of cross section of another conductor of same material and same resistor but length is 2L. Okay, so another conductor they took, okay, and they have the length here 2L, okay, but the material of this first conductor and second conductor should be same. Material is same and here only the length is L and this length is nothing but twice of L. Okay, and they have a same resistance, means here also it contains a resistance R. Okay, this is given. Then they are asking what is the new area of cross section. Correct, they are asking the area of cross section of the another conductor. We have to find out this. Okay, so we have the condition, we know that rho is equal to we have rho, not rho, we can write R is equal to rho L by A. So this is for first, no, we can write this is rho is equal to R is equal to rho L by A. Okay, so in second case, suppose area of this is I am taking A dash. Okay, so here this is resistance of first conductor, then resistance of the second conductor should be what? Rho, same material, L is nothing but here 2L divided by area is nothing but what? A dash. Okay, can you getting this how I assumed and what I am doing? Okay, but here both are having what? Same resistors, means here also its resistance is R and this resistance is also R. So we can write here R1 is equal to R2. This is given. I am not assuming, this is given in the statement. If they are having both same resistance, then we can equate, no? So we can write rho L by A is nothing but rho twice L divided by A dash. So here rho is get cancelled, L is get cancelled. So new area. So here 1 by A is nothing but twice of A dash. So therefore we can write here A dash is equal to twice of A. Okay, this is what the answer. Now check your option. Here option is C, that is twice the area. Okay, getting this question, copy this. Copy this. Finished? Okay. Now take a next question. Write down. Some work is done to move a charge Q. Write down. Some work is done to move the charge. Capital Q from infinity to a point A. Capital A in a space full stop. The potential of the point A is given as V, capital V. Potential of the point A is given as V, full stop. What is the work done? To move this charge? What is the work done to move this charge from infinity in terms of Q? From infinity in terms of Q and V. Okay, so I will repeat this. Some work is done to move a charge capital Q from infinity to point capital A in the space. The potential of the point capital A is given as V. What is the work done to move this charge from infinity in terms of capital Q and V? Okay, so even in NCERT textbook, second point after resistance, they gave the voltage concept. So we know that here if any work done we want to do to bring the charge from infinity to the desired location. Okay, there is a concept will come, and that concept is nothing but potential difference. Okay, and the here we can say that work done is nothing but what, q into v. Work done is nothing but q into v, sorry, q into v, and this v is nothing but what, work done by charge, that is q. Okay, and the potential difference is measured in terms of volts. Okay, and voltmeter is a device which we are using to measure this voltage, and we are keeping this voltmeter always parallel in the circuit. So this is what the answer they required. So you can write W is equal to Q into V, or V is equal to W by Q. Getting this? Okay. So take a screenshot and write down next question. Ruday, are you there? Who is there? Another? Advait? Okay, write down. Next question. In the experiment to study the dependence of current, in the experiment to study the dependence of current I, dependence of current I on the potential difference V, on the potential difference V across resistor, a student obtained a graph as shown. A student obtained a graph as shown, comma, what does the graph depict? What does the graph depict about the dependence, about the dependence of current on the potential difference, current on the potential difference, question mark. Next, find the current that flow through the resistor, when the potential difference across it is 2.5 volt. Across it is 2.5 volt. I will repeat. In the experiment to study the dependence of current I on the potential difference V across a resistor, a student obtained a graph as shown. What does the graph depict about the dependence of current on the potential difference? Find the current that flows through the resistor when the potential difference across it is 2.5 volt. Okay, and here graph is given. Okay, draw the graph for this question. This kind of questions they are asking, practical type questions they are asking from this chapter. So graph is given, draw the graph. Here along the x-axis we have voltage V, and here we have a current, that is I. Okay, and here scale is given 1, 2, 3, 4, and here the scale is given 0.1, 0.2, 0.3 and 0.4, and the current is given in terms of ampere. Here always check on the graph whether they are giving in amperes or milliampere. Okay, volt or millivolt, like that you have to check. And here they drew the graph. Something, we have a graph like this. Okay, This is what they gave a graph. That's it. Okay. So from this we have to write the answer. Okay. So it is very simple. Just now at the beginning of this session I explained you the Ohm's law. Okay, and the question is that here they are saying question. First one, in experiment the study dependence of a current on the potential difference across the resistor. Student obtain the graph as shown. So first they are asking what does the graph depict about the dependence of current and potential difference. Okay. So if you check, when current is 0.1, voltage is nothing but what? 1 volt. When the voltage is 2, then current is 0.2. When voltage is 3, current is 0.3. When voltage is 4, current is 0.4. That means we can write here first bit, V is directly proportional to current I. Okay, this depicts the graph of Ohm's law, and Ohm's law says that if we are increasing voltage, then current is also increases. You have to elaborate this answer and you have to write. Okay, both are a direct proportion. Simultaneously, both the quantities either increases or decreases. But here the graph is what? Increasing. Now second part they are asking here, find the current that flows through the resistor when the potential difference across it is 2.5. Okay, so when 2.5 potential difference is given, that is 2.5 volt. Okay, and we have to calculate here the answer current for this. So here at least by using this graph, because here we have V is equal to IR. So calculate the resistance, because V and I values you know. You can choose any one value. Okay, suppose here if I want to calculate, I am writing V by I. So I am taking voltage is 1 and ampere current I am getting here 0.1. If you are taking voltage 2, then current should be 0.2. If you are choosing current 3, then voltage 3 volt, then current should be 0.3. Like that you have to choose. So here 0.1, that is 1 by 10. So resistance is nothing but what here we are getting 10 ohm. Okay, once you get 10 ohm, they are asking here the voltage is this much, and what is the current value. To get this answer, again I will write V is equal to I into R. So V is given 2.5. I is nothing but we have to find out, and this is 10. So I is equal to what? 2.5 divided by 10. So you can find out here 0.25 ampere is the current. Getting this? So this is what 2-mark question. Sometimes they ask this kind of questions. Getting this? Copy this. Finished? Copied everyone? Write down next question. Write down next question. Draw a labeled circuit diagram. Draw a labeled circuit diagram to study the relationship between the current I. Draw the labeled circuit diagram to study the relationship between the current I flowing through a conductor and the potential difference V applied across its two ends. applied across its two ends, full stop. State the formula correlating the I, capital I, that is current. State the formula correlating the I in the conductor and the V across it, and V, capital V means voltage, V across it. Also show their relationship by drawing, and also show their relationship by drawing a diagram, what would be the resistance. Hi Raghav. Also show, by drawing diagram, full stop. Next, what would be the resistance of a resistor? What would be the resistance of a resistor if the current flowing through it is 0.15 ampere, 0.15 ampere, when potential difference across, when the potential difference across it is 1.05 volt, 1.05 volt. Okay, I'll repeat this question. Draw label circuit diagrams to study the relationship between the current I flowing through a conductor and the potential difference V applied across its two ends. State the formula correlating the I, that is current, in the conductor and the voltage V across it. Also show their relationship by drawing the diagram. What would be the resistance of the resistor if the current flowing through it is 0.15 ampere when the potential difference across it is 1.05 volt. Okay, this is 3-mark question they gave. So here draw label circuit diagram. Okay, circuit diagram to what? To study the relationship between current I and the voltage. Okay, and we have to show the potential difference, and we have to show the formula also, correlating formula with that label circuit diagram. Okay, they will ask the same question but in different way. Okay, so here V, I, whatever it may be, so we know that V and I are in direct proportion. First we have to draw the label diagram here. So you can draw a battery first. Okay, so you can join here ammeter and then take a resistance. Okay, name it as a R. Then connect here one voltmeter which is parallel to this resistor. Okay, and then with the help of key, key is closed, then only current can flow through this circuit. Resistance, this is, you can take it as a positive, negative, and you can complete this diagram. Okay, so this is drawing of the diagram, gives 1 mark. This is a label diagram, and we know that as here battery voltage is increases, V is directly proportional to I, then V is nothing but I into R. This is according to Ohm's. This is according to the Ohm's law. We will write V is equal to I into IR, and here values are given. If voltage is 1.05 volt, then their current is given 0.15 ampere. Okay, they are asking value for R. R is nothing but V by I. V is 1.05 upon 0.15. So here directly this 0 get cancelled. Okay, this 0 R get cancelled, and 15 sevens are 105. Okay, So answer you will get here 7 ohm. So this is nothing but what? The resistance R. Okay, copy this. This question they ask for 3 marks. Copy this. Okay, write down next question. Write down next question. First bit, take a screenshot and write down next question. First bit, name the instrument that measures. Name an instrument that measures electric current in the circuit. Electric current in the circuit. Full stop. Define unit of electric current. Define unit of electric current. Define unit of electric current. Second bit, write down. I'll repeat first bit again. Name the instrument that measures electric current in the circuit. Name an instrument that measures electric current in the circuit. Define a unit of electric current. Second bit, what are the following symbols mean in an electric circuit? What are the following symbols? What are the following symbols mean in an electric circuit? Okay, so these are the symbols they gave, and here we have an arrow, and this is first and second bit is given. Okay, this is second symbol. Draw this A and B. Then write down third bit from the same question. Write down third bit. Draw a closed circuit diagram. Draw a closed circuit diagram consisting of 0.5 meter long nichrome wire XY, an ammeter, voltmeter, four cells of 1.5 volt and a plug key. Okay, I'll repeat this third bit. Draw a closed circuit diagram consisting of 0.5 meter long nichrome wire XY, an ammeter, voltmeter, 4 cells of 1.5 volt and plug key. Okay, so this is a question. They asked this question for 4 marks. Okay, so first is for 1 mark, second bit is also 1 mark, and third bit is asking for 2 marks. Okay, so the first question they are asking, name the instrument. Okay, so first bit they are asking, name the instrument which can measure the electric current in the circuit and define that electric current. Okay, so it's easy, no? Just now at the beginning of this session, name the instrument. We are current is measured with the help of ammeter. Okay, current we are measuring with the help of ammeter, and current is nothing but what? Flowing of electrons, or movement of the charges whenever we are providing the supply or energy to them. Okay, so here just wait. So we can write here yeah, current is nothing but how much current. We can say that if 1 coulomb of charge is flowing through it for the given cross sectional conductor, okay, for a given period of time, is nothing but current. That constitutes the current. I gave this formula also, I is equal to Q by T. So current we are measuring in terms of ampere with the help of device ammeter. Okay, then after that second bit is to identify these devices. This is what a variable resistor, or you can write rheostat. This is a rheostat, or you can say that here variable resistor. Variable resistor, and this is nothing but what? Key. That is also what? Closed. Closed means here already the current is flowing. That means is a symbol of key or plug key. You can say that. Okay, people can write plug key also is okay. So this is nothing but what? Second bit. Then third bit is what here they are asking. They are asking to use micro wire XY, and in that micro wire we have a resistance, this R, this is X and Y. They are asking us to use, I think, 4 cells. 1, 2. Okay. So these are the cells or batteries we are using. Then they are asking us to use the plug key. Okay, and then voltmeter and ammeter is also there. Okay, ammeter I will draw it over here, which is always in series, and voltmeter also they are asking. No, R I will write here. So voltmeter I will draw it over here. So this is positive, negative, positive, negative. This is a key K, and we have here 4 cells. Okay, and each of having 1.5 volt into 4. So this is nothing but what? Battery which we provided over here. Okay, and this XY is how much? 0.5 meter long. So this is what the circuit diagram. Okay, so always remember ammeter is always we are connecting in series, and voltmeter we are always connecting in a parallel. Okay, getting this? Draw this, take a screenshot. Okay, take a screenshot, or you can just note it down. I'll come in 1 minute. Okay, finish this. Copied everyone. Okay, finished. Okay, write down next question. Write down very IMP question. State Ohm's law. State Ohm's law. Full stop. Draw the circuit diagram. Draw the circuit diagram. Draw the circuit diagram. to verify this law, indicating the potential indicating the positive and negative terminals of the battery of the battery and the meters also full stop also show the direction of current and also show the direction of current and also show the direction of current in the circuit. Okay, so here I will repeat this question. State Ohm's law, full stop. Draw the circuit diagram to verify this law, indicating the positive and negative terminals of the battery and the meters also show the direction of current in the circuit. Okay, so you can explain Ohm's law. Already I discussed during this session many times. Ohm's law is nothing but what? V is directly proportional to I. If we increasing the voltage, current is also increases, and we can write V is equal to IR. Okay, and show the graph also and verify the law indicating positive and negative terminals of the battery and meters also show the direction of current in the circuit. Okay, so you have to draw the diagram first here. But to explain Ohm's law, then you have to draw the diagram. Okay, so if you are using, okay, I will show you what should contain in this answer is very important. First, 1 mark they are giving to write the correct Ohm's law. So here V is directly proportional to I. So V is equal to what? IR. So second, what you have to draw the diagram here. Okay, where ammeter and here across this we have a voltmeter. Okay, then we have the battery supply over here and we have a key, plug key. So this is key. So positive, negative ammeter, this is resistance, voltmeter, and this is positive and negative current is flowing through this. This is a diagram, and how to check this Ohm's law, verify, you have to draw the diagram, here current and here voltmeter. You will get a graph, and this graph gives the value of resistance. So these points should contain in this answer, then only you will get full marks for this question. Can you getting this? Can you able to understand what is the diagram here given here? Okay, so these are the required points we require to write this. Okay, so now next question. This also you have to do it as a homework. Write down next question. List the factors on which the resistance of the conductor in the shape of wire depends full stop. Second bit, why are metals good conductors of electricity whereas glass is a bad conductor of electricity. Give a reason. Third bit, why are alloys commonly used? Why alloys are commonly used in the electrical heating devices? Give reason. Give reason. I will repeat this question. List the four factors. Sorry, list the factors on which the resistance of a conductor in the shape of wire depends. B. Why the metals are good conductors of electricity, whereas glass is a bad conductor of electricity. Give the reason. And last, why are alloys commonly used in the electrical heating devices? Give a reason. Okay. So list four factors of the resistance of a conductor in the shape of given wire. Okay. So factors which are depend, resistance is depend on. This also I explained, but what point should come, that I will explain you. Here R is equal to, we have R is equal to rho L by A. It depends on the length and the area of cross section, and depending upon the given material also, and temperature. And here this is answer for first wire, first question. Second, why metals are good conductor? So metals are having what? Free electrons, okay, or they are having what? More electrons in it. So because of the more electrons, more free electrons, they can conduct the they can conduct electricity, or they constitute the electricity. Okay, so bad here glass is a bad conductor because there is a no free electrons are present in the glass. So this is the second bit answer. And last, why alloys are commonly used in the electrical heating devices? Very important. Alloys are having high resistivity. Very important. Alloys having high resistivity, high melting point, okay, high melting point, as well as they will not oxidize readily at a high temperature. They never oxidize at high temperature. Not oxidize at high temperature. Okay, this is the answer. So I finished the first part. Of this chapter. So maybe today afternoon or tomorrow morning I'll keep the session for the second part of this chapter. Okay, so you can learn all the basics from this, whatever I taught. Okay, thank you. I will end this session.